given so given the system is a unity feedback system, so that means h of s is equal to 1, and the forward path transfer function is given by g of s is equal to divided by s multiplied by 1 plus 0.6 s multiplied by 1 plus 0.4 s. Okay. And question is, you have to determine the range of value of k. Range of value of k as well as frequency of sustained oscillations. So how will you find it? First of all, you have to form the ROUTH array. So that we need the characteristic equation of the given system. So the characteristic equation is 1 plus g of s h of s is equal to 0. So if you substitute the gain values in this relation, 1 plus 0.6s multiplied by 1 plus 0.4s is equal to 0. So finally you will get the polynomial as s plus 0.6 s square multiplied by 1 plus 0.4 s plus k is equal to 0. So if you further solve this, it will become 0.24 s square, no, not s square, s cube plus s square plus s plus k equal to 0. Is it right? So if any mistake is there, please let me know. Okay. So this is the characteristic polynomial. So next step is to form the ROUTH array, so that we can start the power of s from the higher order to lower order. That is s3, s square, s power 1, s raised to 0. Right now we have to enter the corresponding elements. That is 0.24, 1, 1, k. Right. So how will you find this value? That is 1 into 1 minus k times 0.24 divided by 1. So this becomes 1 minus 0.24 k. Another element becomes 0. And what about this one? This becomes k, right? So first we have to find the range at what range of value the system becomes stable, right? So according to ROUTH array, if you take the first column, in order to be in stable state, all the elements in the first column must be a, there should not be any sign change, right? So that means this should be positive, this should be positive, this should be positive, and this should be positive. So when this becomes positive, and find 1 minus 0.24k should be greater than 0. Then only that value will become positive, right? So from this you can find the value of k. Is greater than, so we will get k as the 100/24. How much it will come? Now this also has to be greater than 0. So what is the range of value? So range can be written as 0 less than k less than 4.16. Right. Now, how will we find the frequency of sustained oscillation? How will you find? Can you tell? When the output response will oscillate? The roots lies on the j omega axis, right? So how can we form that? So set this value as 0. Yes, I will rewrite this again. S3 S square S power 1 0. First one is 24 1 1 k. So if I take 1 minus 0.24k is 0, what will happen? What will happen? The entire row element becomes 0, right? So in last class we have seen, if all the elements in a row become 0, what is the procedure to complete the computation process? We have to form an auxiliary polynomial just above the 0 element row, right? So how can we form the auxiliary equation? This s square plus s square plus yeah, k equal to 0, right? So how can we find the pole? The poles will be plus or minus j root k. But what is the value of k? At what value of k this becomes 0? 1 minus 0.24k is equal to 0 when it becomes 0, when k equal to 4.16. Now you substitute this k here, you will get s equal to plus or minus say root 4.167. So this becomes, if you take the root, it becomes 2 point something. How much? Plus or minus j? Two point 041. Now, how will you find the natural frequency of oscillation? Now it is clear that both the poles are lying on the j omega axis, right? So, what is the frequency of oscillation? It's 2.041 radians per second. Clear? Okay. Note of this question. For a system having characteristic equation, for a system having characteristic equation 2 s raised to 4 plus 4 s square plus 1 is equal to 0. So we have to find out the number of roots in RSP, LSP, and j omega axis, and check the stability of the system. How will you do it? So this characteristic equation can be rewritten as, because some s terms are missing, right? So we can write like this: 2s power 4 plus 0 s cube plus 0 s square sorry 4 square plus 0s plus 1 is equal to 0. Now you form the root array. So it will become s power 4 s cube s power 0 s power 1 0. So start entering the elements 2 0 4 0 1 0. Okay. So now we have observed that the elements, the row corresponds to s cube becomes 0. All the elements corresponds to s cube becomes 0. Right? So what we have to do? We have to form the auxiliary equation using this polynomial, right? Corresponds to S4. So what is the auxiliary equation? Auxiliary equation becomes 2 s power 4 plus 4 s square, right? We have to reduce the order by 2 plus 1 is equal to 0. So in order to continue the computation process, what we have to do? We have to differentiate the auxiliary equation, that is d, let this be dA of s. Okay. So you have to differentiate this dp of s by ds is equal to 8 s cube plus 8s. Here now using this polynomial, we have to complete the entire 0 element, right? So you can replace the 0 with 8. Again, you can replace this 0 with 8. Here. Now you can continue the computation process. So if you do this, 32 minus 16 by 8. So it will become 16 by 8, 2. Again 8 minus 0 by 8, it becomes 1. Then this is 0 again. So next one, 2 into 8, 16. 16 minus 8 by 2. So it becomes 4. Right? And this becomes, and the next one becomes 4 minus 0 by 4. So here, so I hope everyone know how to do it. Okay, so if you have any doubt, please ask. Okay, and you have to work out more problems also. Have you downloaded the textbook which I told you, right? That's the textbook name. You have the PDF? Compound System Engineering by Government Rights. That lot of numeric examples are there. Do you have that textbook? Yeah. So please work more problems. You practice it. If your exam is on offline, you know, right? In between, if you have any doubt, please ask. So now we will, according to ROUTH-HURWITZ criterion, we have to take the first column of the root array and see any sign change is there or no. Right. So one thing is clear that there is no sign change because this is positive, this is positive, this is positive, this is positive, this is positive. So what is the meaning? Since there is no sign change, right. So what is the inference from this? Since there is no sign change, how many roots lies on the RSP? 0. So there are no roots lies on the RSP of the display, right? In this problem, we have 4 roots, right? So we need to find where the other 4 poles are located. Now, for that, what we have to do? You just find the poles from the auxiliary equation, right? So our auxiliary equation is 2s power 4 plus 4 s square plus 1 equal to 0. So how will you find the roots? You find the roots and tell me. It can be written like this. We converted this 4th order to a 2nd order. So if I solve this, how will I get s square is equal to minus b plus or minus root of b square minus 4ac. b square becomes 16 minus 4ac 2 into 1 whole divided by 2a. 2 into 2 is 4. So s square becomes minus minus 1 plus or minus root of 16 minus 8. That is root 8, right? So how much it will come? You calculate and tell me. What is the value I am getting here? You tell me that the value full minus the 2 roots you tell me. Anyway, there is no conjugate, right? Means complex term is there, only real values there. Tell me the 2 roots minus 1 plus or minus 0.707. So the first root becomes minus 1 plus 0.707, right? So it becomes, how much will become? How much will become? 0.707. Any mistake is there, you once again check it whether I am doing correct or not on this. Minus 4 by 4 plus or minus. This is not 2, this is 4 actually. Correct. Now you check it once again. I think we are doing mistake because denominator 4 only will be there, right?
Correct only, sir.
Oh, this final value is correct only, right? Okay, then. Okay. So now that is s square, right? Our aim is to find s. S becomes square root of minus 0.292 or square root of minus 1.707. So this can be written as plus or minus j. Can you tell me the root of 0.25? Sorry, 0.292. And root of 1.707. 0.540. The other one? .306. Okay. So here we have two complex conjugates. Again, here also we have two complex conjugates. So as per the rule, we have studied that if auxiliary, all the elements in a particular row become 0, we have to form the auxiliary equation. In such case, what is the behavior of the poles? Means that poles which, tell me. So what is the behavior of that pole? And one more thing we have studied, right? What is the specialty of that pole locations? If they will be radially opposite poles, right? Last class we have discussed. Do you remember that? The poles which we are obtained through auxiliary equation, what is the behavior of that particular pole? That stays radially opposite, right? So if we take the first one is J.540 and there will be a minus J.540. So you can see that both these poles are radially opposite. And one more thing, one more set pole is there, that is plus 1.306 and this becomes minus J.1.30. So how many roots lie on LHP? Because in the given polynomial only 4 poles are there, right? 0. So number of poles in LHP is equal to 0. Number of poles in J omega axis, that is also that is equal to 4, right? And first we have observed that the number of poles in RHP is also 0. So from this, what is the stability condition? Whether the system is stable, unstable? So according to HURWITZ, that is the unstable. Right? Why it is unstable? Yeah, critically stable, right? So what are the conditions for unstable system? Either poles to be in RHP or there should be multiple poles on the j omega axis, right? There in this case there is no multiple pole. This is different, this is different, this is different, and this is different, right? So that means it is a critically damped system. Sorry, marginally stable system. It's a marginally stable system. Clear? Any doubt, please? Okay. What is this characteristic equation? Given that the characteristic polynomial is SQ plus 20s square plus 16s plus 16k equal to 0, where k is the system rate. So you have to find first one, range of k for the system is stable, and the second one, the value of k for the system to oscillate. So at what value of k the system response will oscillate, and also you have to find at what frequency it is oscillating and corresponding frequency of oscillation. Corresponding frequency of oscillation. Yeah, you calculate and tell me. Everyone, please do it and tell me what is the range of k for the system to be in stable state, and at what value of k the system can oscillate, and also if it is oscillating, what is the natural frequency of oscillation. So please do it and tell me. I will call one roll number. He has to present the result. Okay. Acha, what is the strength of your class? 60. So what happened to the remaining 12? Any idea? Today only 40. No, today only 47%. 13 students are absent. Hope everyone know how much percentage of attendance is required to attend the final exam, everything. So anyway, once it is come, yeah. No, I will call one by one. No need. I will call. So still now I have completed almost 2 units. Today I am completing 2 units. I got only response from one student. Sometimes one more boy is responding. I don't know what it is. Only one boy is responding. Because it is not that I am simply sitting and telling something, you people are doing something. Okay, so I will call one by one, you have to tell the answer. Otherwise, I won't take the remaining modules. You have to respond. Who is roll number 29?
Yes, sir. Vamsi, sir.
Vamsi. What? Your name? Vamsi.
Yes, sir.
Yeah. You tell me the answer. What is the range of K?
Yes, sir. For stable, it should be 0 less than K less than 20, sir.
Okay. Fine, fine. Thank you. You can mute your mic. Who is roll number 20? Roll number 20. And is absent. Roll number 49. Submit. 49. Please unmute your mic. Roll number 49. Submit. Please unmute your mic. Are you there? Okay, let roll 49. I will not on this number. If he is there, means he has to respond, right? I don't know what he is doing there, whether he is available there, that side, or I don't know. Okay, I will call. Who is 40? 40.
Sir.
What's your name?
Kasi, sir.
Kasi. You are from which place?
I am from AP, sir.
AP. Right. So, please tell me at what value of K the system oscillates.
Sir, I have to prepare some more, sir, because I have some doubts in the chapter.
See, please don't tell stories, okay? Till now, I have taken how many classes? Every class I am asking, what is your doubt? Whether you have called me?
Sir?
Till now, at least one time you called me and asked me doubt?
No, sir, but I have to prepare.
What you have to prepare? Right? How many problems I am doing? I clearly writing everything on the board. And every time asking, if you have any doubt, please ask. See, just you see the above problem. If you copy that, you can do it. You don't tell stories, okay?
Wait.
You calculate and tell me. Then only I will continue my class. Then what is the, I don't know. I simply sitting this side and writing something. Only 2 boys are responding. And there is an integrated lab also. From starting onwards, I am telling the same thing. Next semester, you have a lab related with this course. I don't know what you will do there. You have to learn, right? We are spending that much time. You are thinking everything I am telling you from my memory, right? And it's not like that. We are also studying from some source, and after that only we are presenting, because we are expecting some output from that. Otherwise, I don't need to teach this and that. Simply, I'll tell one problem and leave, right? You tell me.
Yes.
You go through the previous problem and tell me what is the K, at what value of K the system is oscillating.
K is equal to 20, sir.
K equal to 20.
Yes, sir.
How? So how you are telling K at K equal to 20 the system is oscillating?
Sir. 1 second.
You take your time.
Okay.
You just go through the previous problem. See, I don't know. You are writing exam on offline mode, first week of March. I will not keep any all questions will be problems only. At that time, you don't tell, sir, I have doubt, I have doubt. If you have doubt, please clear it now and go. Because next module onwards, the concept will be different.
So
What is the value of K?
K value is 20, sir. At third row,
So
16 minus
okay,
0.8K is equal to 0.
So how you are telling at K equal to 20, the system response will oscillate?
I didn't got your question, sir.
Sir, according to our discussion, so the question is we have to find the natural frequency of oscillation, right?
Yes, sir.
So why you are telling at K equal to 20, there is a chance of oscillation in the output?
By ROUTH with criteria, sir.
So if you put K equal to 20, what will happen to the ROUTH array? So in that third row, S power 1, you are substituting K equal to 20, right?
Yes, sir.
Yeah, so when you substitute K equal to 20, what will happen to the ROUTH array? That is my question.
Wait for 1 minute, sir. I want to.
You take your own time, no problem. We have 10 more minutes.
Okay, sir.
So others, please do the problem and complete it and be ready. I will ask questions. If I did not get any response from your side, I will not continue the course. That's what I will say.
Sir, according to ROUTH with criteria, the third row will be 0. Then we will get the K value is equal to 20.
Yeah, so even all the elements in a particular row become 0, there is a chance of system oscillation, right? Okay.
Yes, sir.
Okay, now you can unmute your mic. Sorry, mute your mic.
Thank you, sir.
Yeah. Right. Now, who is roll number 19? 19. Roll number 19. M. Fatima. So are you there or simply put login and win somewhere? At least you please unmute your mic. So the roll number is 19. Okay. I'm not in the roll number. So 90 is absent today. Okay. 19 and 49. I will not consider as a present. Who is roll number 54?
Yes, sir.
Yeah, what's your name?
Shreya.
Shreya, you are from this place?
Kerala, sir.
Kerala. Kerala, this place?
Kannur, Talasheri.
Kannur, Talasheri. Okay, fine. So you tell me at what is the frequency of oscillation?
4 rad per second.
4 rads per second. How you arrived in that?
Like in the S square row, it will be like plus or minus j omega n. After finding that value of S frequency, it will be 4. Like 20x square plus 16 into 20 equal to 0. And after arriving that, we will get.
Yeah, okay, fine. So the system having 2 poles at j omega axis, right?
Yes, sir.
So according to you, from this analysis, where will be the other pole? Because we have three number of poles in the system, right?
Yes, sir.
Because the order is 3, so now we have find out that 2 poles are lying on the j omega axis. So according to you, where will be the other one, third pole?
It will be on LHP, sir. LHP, like no sign change is there. And there is no root on RHP, so there will be a root on LHP, I guess.
LHP. So whether any roots is located at the origin, is there any chance at the origin?
Since constant is there, it will be not there, Paul sir.
What is the constant from our polynomial?
It
Which
is
constant you are taking?
16k. That is 16
Yeah.
into 20, 320.
Yeah, fine.
Okay, sir.
So obviously the other root will be in the LHP, right? Yeah.
Okay, sir.
Okay, thank you. You can mute your mic.
Okay, sir. Thank you.
Yeah. Now, who is roll number 58? Sweta. See, if you are not responding, I will consider you are absent. Okay. Please you unmute your mic. With 58 also absent, right? Yeah. 54 is present, 19 is absent, 49 is absent, 58 is absent. Roll number 59?
Present, sir.
Yeah, okay, fine. Now you tell me, what is the system stability condition? Whether it is stable, unstable, or marginally stable? $58. Okay, 59, right? Yeah, 59.
So if k lies between 0 to 20, then it's stable, sir. If it is greater, then it's oscillating, sir.
It's not stable. And what about other two roots? It is positive. That means that the system doesn't have any pole on the right side, right? So you are telling the system is stable. So you are unmute your mic. See, this is not an evaluation. Just I want to know how much you understand from the class. Okay. Roll number 59. Please unmute your mic.
I'm sorry, sir. I do not listen to the class.
I don't know. Till now, around almost 20 plus class I have taken. So you have not listened to means I don't know how remaining classes, I don't know how you will understand. This is the problem. From starting inwards, I mentioned the importance of this subject. It's very, very simple concept. Okay, please unmute your mic. Sir, mute your mic. So roll number 58, 49, and 90. Today I will consider them as absent. It is not a button. Daily routine. Simply you have to switch on your mic, everything, and attend the class, and you have to listen. One more problem I will give tomorrow. Anyway, I will call one by one. If you are able to answer it, we will continue the course. Okay. So study properly and come tomorrow. We'll solve this problem also. Not on this question. So this will be a homework problem. The partial ROUTH array of the characteristic equation is given below. In this question, this is a reverse question. Root array itself they have given. This partial root array will be given. Is having highest order of 4, and the corresponding elements are 1, A, 8. The second one, 3, 2. The question is, the system oscillates with a frequency of 2 radians per second. And they have also given that the given system is having some oscillation, and that particular frequency of oscillation is 2 radians per second. Okay. Now the question is, find A. You have to find the value of A from these two. Clear? So please do this and come tomorrow. Likewise, I will call one by one. I need the exact result for this, and if you are telling some value, you have to justify your answer. Clear? Any doubt in this question? I think for partial root array is given, the system is oscillating, and the frequency of oscillation also given. The thing is, you have to find the value of A. Do it and come. Okay. So today you can leave the meeting. If you don't have any doubt, please leave the meeting. Otherwise you ask.